So this is the second part of mega container ship. This is already mentioned in the last class. Why we want to make container carriers big? It is because resistance is proportional to the area of the surface, but the capacity is proportional to its volume. So we can get the merit of the size. The result is V is volume and I think I'm sorry. This is. I'm just confused. I modified this slide, but actually, I checked. This should be power divided by volume because I want to show you the cost per TEU. So let me check later. But the result is the same. This should be required power per container volume. So the cost is proportional to the volume powered by minus 1/3. So if we increase volume of the vessel about 30%, approximately the required power per cargo will be decreased by 10%. So in the last class, I discussed partially the problems of.
On this slide, what is this sign between V and L to the power 3?
This one?
Yeah.
It says this is not a velocity, it is a volume. So volume of the container vessel is proportional to the cube of the length. And resistance is proportional to the square because it is proportional to surface area. So the result is this one. Other merits of large container ship is its manning cost. Manning cost because even if the size of the vessel is doubled, we don't require double the number of crew members. Also, if the container ship is big, it can utilize the largest gantry crane in the port. Actually, a large ship have some demerits. So this is already mentioned in the last classes. The demerit is long time of load and unload. And also, huge structure requires higher research and development cost. So next, I'd like to show you the problems related to building mega container ship. It will be categorized in 4 parts: general arrangement, structural strength, and propulsion, and its finance. First, general arrangement. This is already a big container ship. If it is a standard container ship, it will be like this. The main structure, we call it island. Shipbuilders called it island because it is a kind of mountain in the sea of containers. This is a standard layout, but actually, in this configuration, engines are installed in the after part of the ship, so it will lead to concentration of weight load in the limited area. So in large vessel, they want to shift island and engine part to forward position. Also, this arrangement have another merit. There is a regulation of number of stacked containers to get the good visibility in front direction. So moving the island in forward position is beneficial to reducing this reduced number of containers. But if we move this island to forward, it will require longer transmission lengths. Usually it will be done by long propeller shaft. Propeller shaft is if we move engine forward, we have to install longer propeller shaft. Propeller shaft is very heavy material. It has to bear the torque of the engine, so it is very heavy and it is not easy to manufacturing. So there will be a compromise between weight and possible capacity of the cargoes. Also, large structure is not easy to build. If you if you have experience of visiting shipbuilding yard, shipbuilding company, you will see very thick plate, but it is actually not thick in comparison to the size of the vessel. So actually, a ship is not a rigid structure. So major problem is they are in water. They are floating in free surface, water surface. The severe condition is sagging condition and hogging condition. Sagging is suspended in forward and rear part. When wave is in this position, the higher free surface will lift up the ship slightly higher, and in the hollow of the free surface, the reduced buoyancy indicates the mid part is sagging. So it is similar to this condition. The ship is suffering from this type of stress. And if in other phase of the wave, the wave peak is in the mid of the ship. So in this case, the ship is suffering this condition. So problem is ships are repeatedly suffering this type of load in severe sea condition. Hogging, the name hogging comes from the shape of the back of pig, I guess, but I'm not sure. Other mode of stress is racking. actually, a ship does not go straight to wavefront. So the relative position of wave and the ship is different in forward part and rear part. So this picture indicates it has higher water level in this side and it is lower in this side. So in this section, the section gets the torque of this direction. But this torque is different in ship length wise. So it will make the torque load on the ship. So it is called locking. It is equivalent to torture of the ship. If ship is small, the load of these type of load will be reduced. But naturally, if it is very large one, it is a very severe problem. Even when we will build twice as large as larger ship, the thickness of the plate will not the thickness of the plate does not increase in the same ratio. It is not logical. So we want to build large ship with thin plate as possible as we can. So for your consideration, please see this animation. It is a severe condition of container vessel. The size of the container vessel is 4,500 TEU. Please see this video. It shows the working corridor inside the container vessel. What you can see? The ship is not rigid in this severe condition. It shows the accelerate. I guess it is barometer. So ship is not going straight to the wave. Actually, the captain select oblique course to reduce the load of the ship.
Did it work?
Did it work?
Did it sink or did it?
No, it is not. It is very frequently experienced condition. The course of the vessel is in eastbound route from Asia to United States. So it is North Pacific Sea. Usually it is not so rough, but this is not a rare case. So actually what I'd like to show is the condition of this one. So if you are employed in shipbuilding companies, you will have the opportunity of seeing this one. But I think it is not a not a happy experience. So we have to prepare this kind of load, and it is not an easy task. So if we want to build large container vessel, the plate thickness of the plate also increases. This shows the hatch side combing plate thickness. It is in this part. The container ship is difficult to build because if it has its sectional shape is closed, it is easier to build, but it has opening for the efficiency of loading and unloading. So if you have experience in mechanical engineering, the difference of this one and the previous one is very significant. Since this structure experiences bending moment, we have to use thick material in this part and this part, because the neutral axis will be in the middle of the depth of the ship. But because of this opening, this part it cannot be used for strength and structure. So what we can do is only use very thick plate in this position. So the position is the name of the position is combing top. It is indicated in this part. So the thickness of this part is it was around 30 millimeter when container size is 2000 TEU, but it is now 100 millimeter. So if we want to utilize very thick iron plate, it leads to the difficulty of welding. Welding, do you know welding? Okay. So if the welding requires melting iron plate, but if iron plate is very thick, we cannot provide uniformity of this part. If only one side is welded, it is a very severe condition, because it will experience concentration of stress in the other side. Also, large container vessel indicate the requirement of damage control. We have, although we'd like to have good structure, we have to consider its fading phase. Damage control indicates when one part is broken and the crack is expanding. The crack should be captured in one part to avoid the overall destruction. So it requires higher engineering knowledge for the designing. So I said thickness of the plate is actually the plate of the ship is not thick enough. It shows one analogy. Please consider please consider the miniaturization of the ship. I'm considering 400 meter length ship, and it has 100 millimeter thickness of combing top. If the ship length is 2 meter, similar to your height, the thickness of 100 millimeter will be only 0.5 millimeter. Already this is the level of aluminum foil. But this 100 millimeter is very special position. It requires very thick plate. So in most of the cases, the thickness of the hull of 2 meter length ship will be less than the thickness of aluminum foil. So in movies of Godzilla or other things, the creature will lift up vessel, but it does not happen, because when we lift up the vessel, it will destroy immediately, because it is not prepared for such kind of load. The merit of sea-going vessel is its distributed weight. It is supported by buoyancy, so we can load heavy load. If the load is concentrated, it will immediately destroyed. Other consideration of structure is its dynamic part. They are called whipping and springing. Whipping is deformation of a container ship in seaway due to whipping effects caused by slamming force. A ship is very large, and it will be hit by bow, at the bow by the wave load. And the load will remaining for a while. The ship is whipping, and other one is springing. So the ship experiences repeated load of sagging and hogging, and in the time the shape of the ship will go into will repeatedly go into this shape and this shape. The deformation might be small, but for a passenger or crew inside the ship, it is not negligible. So I think, okay. So this is one example of computational simulation of whipping. It says it is from Germanischer Lloyd group. It is a classification society in Germany. Their analysis shows fluid structure interaction simulation. So although the motion is very small, the ship shows oscillation in structure. I guess it is not significant, but if you see the animation closely, you can see the deformation of the ship. In springing case, also you can see that deformation. It is not the severest condition because wave length is shorter than the ship length. If wave length is equal to the ship, the load will be maximized. So it is a severest condition of the ship. Please check the original one from this Germanischer Lloyd site. If you will see closely, you will see the deformation of the ship. Another consideration is propulsion. High propulsion is required for the very large vessel, but size of the propeller disc is not sufficient because propeller disc size is proportional to the square of the size. But required propulsion increases more than the ratio of the square of ship length, square of ship length. So there will be an increased concern of cavitation. Do you know cavitation of the ship? Propeller blade of the ship is propeller disc is rotating, and its section is like this. Blade is going, and it will generate lift force. The problem is when the speed of the blade is high, it will cause a pressure drop. So low pressure appears here, and in low pressure, the water starts boiling. It is the opposite side of pressurized cooker. Pressurized cooker is by using pressure case. It will increase the temperature of boiled water, and it will it will be an efficient cooking device. But if the water is depressurized, the boiling starts in the water temperature of 20 degrees or any temperatures. If the pressure is low enough, water starts boiling. The problem is so the water starts boiling, and this bubble contains water vapor. It is not hot. It is in the temperature of normal condition, but it is boiling. And when pressure recovers, it will these bubbles collapse again. These bubbles collapse, and when collapse happens, it will generate very high pressure. In the bubble, there is also other gaseous materials. It's when water vapor bubble collapses, other gases will be compressed. It will cause 10,000 degree temperature, and it will, when this collapse happens near the surface of propeller blade, it will destroy the local surfaces, and it will be called corrosion of the propeller blade. So we want to reduce the cavitation, but it is difficult because of the limitation of propeller disc size. So what we can do is reduce the variation of static pressure on the revolution. If the ship is large, propeller disc is also large. So the condition of upper position and the down position is different because the static difference of static pressure in this point and this point. So the static pressure will be lower in upper position. So cavitation happens around here, and it will stop in the bottom position. So this will show repeatedly occurrence of cavitation sheet. Such a repeated phenomena is not good for the structure because it will generate noises and vibration. So for realizing a large capacity vessel, we have to design the incoming flow around the propeller disc to show incoming speed of the propeller will be uniform, will be similar to uniform flow. Also, sometimes one propeller disc is not sufficient for large vessel, but naturally one single large propeller is difficult to construct. So we have to consider two propellers. But actually, two propellers is not efficient than single propeller. So we have to compromise the design between one single propeller and the twin propellers. We will see some example of large container vessel. Emma Maersk class container ship. This is a present largest container vessel. The length of the ship is almost 400 meters. The beam is 56, and the draft is 15.5. So it is almost Malacca Max size. The capacity is about 15,000 TEU. Although the size of the ship is large, the required crew is 13. So it is it does not show a significant increase from smaller vessel. If it is small vessel, it is 10 or 11. I guess so. This is reasonable for considering the cost of manning, cost of crew. The builder is shipyard in Denmark. I guess you cannot imagine how big it is. This is very rare shot because it does not have containers. Island is here, and you can see the entire structure. This ship utilizes single propellers, and the size capacity of the power plant. This is the largest diesel power plant in the world at present. If it is loaded, it will be like this. It is a comparison of vessels. Emma Mask is this one. So this is not the longest ship in the world. We have already a larger ship. This is a crude oil tanker. Its length is 458. So about 400 is not the largest, but it is larger than Queen Mary II and larger than super airplane carrier of the United States. USS Enterprise is not the largest one, but largest one is also in the similar length scale. So you can assume Emma Mask is larger than US aircraft carriers. As I said, large container carriers requires large port. So it requires 11 cranes of 65-meter outreach. Outreach is this length to utilizing the maximum performance of the vessel. If we cannot provide less cranes, the load and unload time will be long. Also, it requires over 15.5 meter draft of quay. That it requires depth in this direction. The waterway we will go tomorrow is on the 6 meter depth, I guess. Yeah. So it is a very large draft. And large draft is very expensive. It requires continuous engineering of the seabed around the port. And container yard requires 200-acre area to handling the containers of the ship. I guess Professor Han already said if the target of container is in the middle of the ship, we have to pull out all the upper containers and pull up one container, and other container have to be returned to the vessel again. So in such a work, we require a large container yard area. I guess I have provided information. Okay.
So when they charge in the port, maybe we charge the cost. So what is the criteria? Because if we arrange the container messed up, maybe the container we should use more time the container, right?
Yes. So if it is a good shipping company, they will manage to avoid such kind of messy operation. They will have computer system to design loading conditions. The information system contains all the schedules of containers when it requires loading and unloading, and it will usually automatically minimize the handling works.
So they all ports sharing the information.
Unfortunately, the sharing is not complete at present. So it is not the ideal optimized condition at present. So sometimes very messy work happens in the port. But they are trying to reduce such kind of additional handling. It is naturally, increased number of handling is not good. If the container if there is Pringles inside the containers, it will destroy the chips. So the next thing is it requires large draft, but this draft is not always possible in major port. Incheon port is not sufficient to accept this size of the vessel because of the shallow water depths. The problem also happens in Shanghai. Shanghai port is now world's biggest port, but Shanghai. This is Shanghai, and this city is built near the large river, Changjiang River. So in this part, Shanghai port, original Shanghai port is here, but it is not sufficient. It does not have sufficient draft to accept mega container ships. So they built other port here. The name is Yanshan Deep Water Port. You can check this port using Google Map, and you will see a 40-kilometer length bridge from Shanghai to the port. This idea might be effective in other port like Incheon.
The length of the bridge is 40 kilometers?
Yes, 40-kilometer bridge. It says 35 kilometer offshore. So this is. It was originally very small island. Actually. Original size of island is like this, and the Chinese built container yard in this scale. So they are almost building new island to accept large container vessel. So it indicates how it is important to accept large container vessel for countries like China, or I think it is also important for Japanese and Korean.
So between this area, they also using some small ship. Because the Arawato Way is just like a 13 kilometer. It's much shorter than this, but if the length 35 kilometer has no economical benefit, maybe 13 kilometer has also no benefit, right?
I think they want to shorter path, but to have the sufficient depth, it have to be 40 kilometer, and it indicates this part is sufficient. This part has sufficient draft, but the depth of water will be decreased in this direction. So if this size of ship goes into Yanshan seaport, it will be changed to trainer truck, and it goes to inside Shanghai, or it will be on other smaller vessel. It will goes to Shanghai port, or it will goes to Changjiang River and goes to River Way to other industrial cities in upstream position. So it is their solution, but you have to find another solution by utilizing the waterway. The size of I said Emma Musk is almost 400 meters, but I guess you cannot imagine how big it is from in the limited information. You can go to shipyard and you can see a very large vessel, but in the occasion, your sense of the size will be paralyzed because it is not a familiar scale of your life. So I will show you some example. This is Panamax Barca. Panamax Barca is here. And this is Suezmax oil tanker. The length is 300 meters, and it is over Panamax container vessel. What I'd like to show is also there's one example. You will see Esso Osaka. This model is hung in the entrance. The actual length of the ship is 343, so still this is smaller than Emma Musk. But we have to compare the size of the ship in our familiar length scale. This is Eureka building. This is 48 meters, about 48 meters. So I guess you know this place and the size of each building. So if we place Panamax Barca, it will be like this. And over Panamax container vessel, and Suezmax container, and this is Esso Osaka. The vessel hung in the entrance will be in this size in actual scale. So I guess Eureka Hall is here, and one restaurant is there. So when you went to this restaurant, please feel the distance from Eureka Hall to this place. It is almost equivalent to you are walking on the deck of Esso Osaka. And Emma Musk is still larger than this one. Okay. Tomorrow you will see some container ship, but Incheon port is not. It does not have sufficient water depth, so the vessel size is slightly small. But please check the information tomorrow, and please compare the size in comparison to present largest vessel in the world. Such a mega container carriers have influences in other aspect. The economy, it is already mentioned. It will enhance the economic performance between hub and hub. So the point is, it is only hub to hub cost reduction. We need hub to spoke transportation. We have to provide other transportation. And this mega container carrier forces consolidation of seaports because it is very large. The ports, those can accept large container vessel is very limited. It requires, if it is Emma Musk, the required container yard is required area of container yard is 200 acres. So I cannot imagine that this area. So I compared to the this area of this campus. This 200 acres is about 800,000 square meters. and it is about 56% of KAIST Daedok campus, this campus. So please imagine over half of this campus will be occupied by containers from one vessel. In this situation, Japanese have some problems. Okay.
How high are the containers stacked for that?
We have to count the numbers. You can see from deck, I think deck is here, so some part is hidden. I guess nine stacks from the deck.
So they also stack it 9 high for the 200 square meters they need for the containers?
In container yard, you mean in container yard? It depends on container yard. It has regulation. On the ship they have girders, but usually we don't have girders in container yard. So in my experience, in China they are stacking 5 containers, but it is 3 in Japan because we have earthquake. So it depends on the condition of container yard. Naturally, they want to stack containers high, but it will lead to some danger, and too high stacking does not contribute to efficiency.
Can I ask? So the port schedule will be FIFO?
Spot schedule?
Will follow the FIFO? First in, first out. I mean, there is a famous port,
Mm-hmm.
and then many ships book this port. I will upload my container. So
it depends on the decision of port authority. Usually, I'm not sure the rule of shipping companies. The schedule is, they will provide schedule of incoming and going container vessels. I'm sorry, I cannot answer your question. But actually, congestion of vessels happens very frequently. The president of this university saw the congestion around Singapore seaport. Then he asked he considers a mobile harbor project. But in the next slides, I will show how it is I will show the loss of money caused by such congestion. So go back to this slide. So Japan is suffering from passing of large container vessels. So it is now called Japan passing, not Japan busing. Japan passing means large container vessel. Trunk line transporter will not stop in Japan. It is because the amount of exports directly from Japan is now reduced because of the high labor cost in the country. So still in Japan we have many manufacturing companies, but their factories are in China or other East Asian countries. So Emma Maersk class large container ship cannot capture the sufficient amount of containers in Japanese seaports. Also, in Japan, industrial cities are distributed in along the long Japanese island. So it is also lead to inefficiency of gathering cargos. I think this slide is not included in the previous PDF because I added this one today. This shows high time value of a vessel. Actually, the value of time is not constant. The value of time depends on the materials contained in the box. But one difference is 7,500 Japanese yen per TEU. This is if one day delay happens, it will lead to the loss of this amount per TEU. So this is only difference value. So there might be expensive containers and very cheaper containers. But if it is this amount, it is 95 US dollars per TEU. So if Emma Musk class container ship delays one day, the potential loss is 1.4 million US dollars. So it is because they pass the Japanese port. This is Google Earth view, and please consider Shanghai or I guess Shanghai or Hong Kong port. Hong Kong and Shanghai is around here, and this is the shortest path to Los Angeles port. You can check this one from Google on Google Earth, and if you change the viewpoint like this, Hong Kong is here, and Shanghai and Busan, and you can recognize Japanese island, and the Korean Peninsula is here, and Los Angeles is here. So this large ship wants to go straight, reducing loss of time as possible as it can. So the present path is like this. From Hong Kong, it will go to here, and it goes to Busan, and they will passing Japan. This is Hokkaido, and this is Japanese main island, and there is very small strait, Tsugaru Strait. Actually, Japan make Tsugaru Strait as a public sea. So international cargo vessels goes to this path. Please consider this path is what mega containers wants to take, and so Busan is in very good position for this consideration. So Busan can be a hub port around here. So I think Japan will utilize Busan port as a hub of Japan more in the near future.
So, I couldn't follow. So how have you decided on the amount, $95 per TEU?
This depends on survey of my colleague. So this value is time value has very variety. It depends on the contents of the cargo. So some cargo contains only clothes, and some cargo contains computers. So there is a very wide variation. So the actual So if we consider more precisely, we have to consider the density function, this probability function of time value. There are very expensive container, but its existence will be very rare. And some are very cheap material. The existence is also rare, but it has some averaged value of the material. So this value is decided by the surveys, very practical survey of the information of port. But actually, as I said, it depends on containers, and average will be also different in each port, because the main exports and imports of the port is different in each countries. Similar view to the westbound route to Europe is like this. It is slightly complicated. Japanese island is here, and the Korean peninsula is here, and Shanghai is around here. And you can recognize the Africa is here and Europe is here. Okay, so the path it is going to like this and goes to Singapore Strait and Malacca Strait, and this is India, and going to Red Sea and going to this is Red Sea and going to Suez Canal and Mediterranean, and go around Portugal. I guess this is Gibraltar Strait, and goes to Europe, Denmark, or other European major seaport. I forgot to say something. This example shows Emma Maersk class container ship, but Emma Maersk is not in this route. Emma Maersk is designed to be operated in this route. Emma Maersk has sister ships, 7 sister ships. Totally 8 Emma Maersk is running in this route. I guess if the company wants to have Asia-US route, they will change some design of the vessel because of the difference of sea state.
Emma Maersk ship is much bigger than Panama's ship.
Mm-hmm.
So this ship is used. Is this ship is using the Panama?
No, it cannot go into the Emma Maersk is slightly larger than New Panamax size. So it is not going into Panama. New Panama Canal is not considered for this vessel. The Emma Maersk size of Emma Maersk is about 15,000 TEU, but possible maximum size of New Panamax will be 12,000. So it is. This is bigger than the expected New Panamax size. So
It's now the Elon Musk she tried to go to Europe, from to Asia to Europe, to transport go down the Africa.
uh,
Routes,
at present, Suez Canal is very convenient for this kind of ship. So I think they they will not consider the larger container ship. It cannot go to Suez Canal. If larger than Suez Canal might be possible, but it is not efficient because the sea state in the lower end of Africa is very severe. So usually we consider it is not efficient for economics. So at present, Elon Musk is the largest one, but the company Musk is preparing next largest ship. It is Triple E Musk container ship. This is Elon Musk, so the next largest vessel is not so large in the length, but the capacity will be increased from 15,000 to 18,000. So the difference, you can see the difference. In Elon Musk Island is here. So the island indicates it has bridges, control room, and funnel. Funnel is also here. So it indicates engine is installed in this position. So it has transmission length of this scale. But in next largest one, Triple E Musk class, the island is it has two islands. This is forward island for bridge, and the second island is for funnel. So they change the general arrangement of the ship.
This triple immersion will have higher draft than the previous ones.
Higher draft than
The previous ones, the 50,500 TEU.
this is present largest one.
Largest one. But as the length is same,
Uh,
the triple immerse will need higher draft.
Yes. It is caused by the engineering works. They bridge is now in this position, so it can utilize full height of their containers. I think this level is caused by the limitation of displacement volume. So with the larger displacement volume, the stacking height will be increased. And also, it has, as I said, it has a limitation caused by a forward view site, forward view. But since island is positioned forward, this is the only deduced stacking caused by view. So the increase of capacity is provided by several engineering works in the new design.
So they have divided the island, the function of the island in two parts.
Yes.
In the rear island and other things in the forward island.
Yes.
So why haven't they shifted that island at the farthest port? So that again the capacity will increase. Why it is still in the near the middle?
there will be, I think there is a compromise in designing. Actually, your indication is very right. There is forward bridge layout. But in side view, you cannot find how thin this position is. So I guess this position is the compromised answer of Maersk or a shipbuilding company. In this position, it has sufficient width, and also if you shift forward island in this position, it will change the weight distribution. At present, two islands are concentrated weight position. So placing heavy weight here and here is a kind of compromised answer at present. Some details will be shown in the next slides. This is some specification of EEE Maersk class ship. EEE indicates economy and something. It will appear later. The builder is Daewoo Shipbuilding. So I think this ship is now under construction in this country. It is 18,000 TEU, so about 2,500 up from the Emma Maersk. Some information says it is equivalent. This capacity is equivalent to freight train of 110 kilometer length. If containers are stacked, the height will be 47 kilometers. Well, anyway, they want to emphasize its capacity. And the prices, I think it is very important to Korea. $190 million US dollars per ship. I think it is not imaginable to your ordinary money. So I have prepared comparison to jetliner. So the present largest jetliner, Airbus 380, is 264 million. So it is cheaper than A380, but Boeing 787 Dreamliner, it is in the similar price. Actually, they have many variations, but you can think it is comparable to Dreamliner. And Daewoo has optional contract of 20 sister ships.
Oh.
Okay.
20 more.
20 more EEE Maersk. But it is option, so it will be final decision will be made after the launch of first EEE. It will be scheduled in the next year. Okay, and length is about 400 meters, so it is only 3 meters longer than previous one. Top speed is 23 knots and 2-island design. So could you over the right? So this it shows. This is computer graphics image, but it shows 2-island design. Bridge is here, and this is funnel. This is second island for funnel. So it indicates engine is in this position. So engine and bridges are separated. So it requires wiring for the control of power plant. And although it is not in high quality, it shows if we can put soccer stadium and I think it is American football stadium and hockey stadium. This is not real. This ship is not designed for this purpose, but the size of the ship is like this. So two-island design is for well-distributed weight because size, as I said, large container ship requires high detailed consideration.
As the frontmost island is almost in the middle.
Slightly
Almost.
forward, almost the middle.
So there is a weight there. So is it free from hogging?
In hogging condition, it will be slightly up.
Yes. So as there is already a stabilized weight there, so will the ship be free from hogging?
No, I think all the ship will suffer from hogging and sagging. Actually, they will be filled with other containers. So the container loading will be distributed. So it is not free from hogging and sagging load. The design is this one provides very good forward sight, and drive train will be shorter than the previous one. And if it shows engine part and still long drive train shaft, and it has two propellers. Because in this size, I think all the shipbuilding companies cannot provide single propeller propulsion. I think it says it will reduce CO2 emission 50% by the increased capacity and new hull design and engine and propeller system and waste heat recovery system. It shows 50% CO2 reduction, but shipping company sees from this chart it will release 50% less fuel. So this for shipping companies it is equivalent to reduction of fuel cost. I think time is reached, so I will stop today's class now. I think I have some other slide. It will be shown in my next class. Okay.